In this video, we will factor quadratic trinomials. Factoring trinomials of the form x squared plus bx plus c. Remember that the first term of the trinomial must have a coefficient of 1 to use this method. The x squared term of the trinomial will have a 1 coefficient. We will be given something in this form, and we will want to factor it as two binomials multiplied together. In order to figure out what these two numbers are going to be, we will use this number riddle. What two numbers multiply to give me c, but those same two numbers add to give me b? So we need to find those two numbers that multiply to get c, which is the constant term, but add to give us b, which is the coefficient on x. So that is our number riddle that we will need to solve for each of these problems. So what we're doing is we're talking about factoring. Before, we were giving two binomials and we FOILed them, combined it like terms, and the result was a trinomial. Now we are going to be given this trinomial, and we want to go back to the factored form. Factoring trinomials of the form x squared plus bx plus c, step-by-step method. First, verify that the expression is a trinomial in the form x squared plus bx plus c. Identify the values of b and c. b is the coefficient of x, and c is the constant. Write two sets of parentheses, as we see here, leaving a space for the number that we will fill in. Write down all pairs of numbers that multiply to equal c. Determine which pair adds to give the number b. Place one of the numbers in each set of the parentheses to complete the binomial factors. Check the answer by using FOIL to multiply the binomials. Our first example. Let's verify this is in x squared plus bx plus c form. It is. We have a 1 coefficient on the x squared term. Our c is equal to 8, and our b is equal to 6. So we need to find two numbers that multiply to give us 8, but add to give us 6. So let's write down all our factor pairs of 8. What two numbers multiply to give us positive 8? Well, we could have 1 times 8 or negative 1 times negative 8. Both of those factor pairs would multiply to give us 8. 2 divides 8, so 2 times 4 multiplies to give us 8, as well as negative 2 times negative 4. 3 does not divide 8, so 3 is not a factor. And we already have a factor of 4 in our lists of factor pairs. So these are all the ways we can multiply to get 8. Now we need to ask ourselves, which factor pair, when I add them, do I get the number 6? 1 plus 8 is not 6, it's 9. Negative 1 plus negative 8 is negative 9. 2 plus 4 is 6. Here is our winning pair. If I multiply 2 times 4, I get 8. And when I add 2 plus 4, I get 6. So we will write our two parentheses. Our two binomials are going to be x plus 2 and x plus 4. Using the numbers that we have determined solving this number riddle, factor pairs of 8 that add to give us 6 are 2 and 4. This is also in the form x squared plus bx plus c. So our c is equal to negative 35. It is important that we see that term as a negative with this minus sign in the trinomial. So we need to find factor pairs, two numbers that multiply to give us 35, but add to give us 2. So let's list our factor pairs of negative 35. So negative 1 and positive 35, and 1 and negative 35. 2 does not divide 35. The number 3 does not divide 35. The number 4 does not divide the number 35. The number 5 divides the number 35, so we can do negative 5 times 7, or we could do 5 times negative 7. These are all the ways we can multiply to get negative 35. Now I need to find the factor pair that when I add them together, I get positive 2. Negative 1 plus 35 is equal to 34, and 1 plus negative 35 is equal to negative 34. Negative 5 plus 7 is equal to 2. So negative 5 and 7 are our numbers that solve this math riddle. Negative 5 times 7 is equal to negative 35, and negative 5 plus 7 is equal to positive 2. So the factored form, we'll write our parentheses and fill in these two binomials with our magic numbers that solve the riddle. So we get x minus 5 and x plus 7. So that is our factored form, and we can check it by foiling. So let's multiply x minus 5 quantity times x plus 7. X times x is equal to x squared. X times 7 is positive 7x. Negative 5 times x is negative 5x. And negative 5 times 7 is negative 35. We have like terms in the middle. 7x minus 5x is positive 2x. So the check is correct, and this is our factored form and our answer. This is in the form x squared plus bx plus c. Our c is equal to negative 12. I need to find two numbers that multiply to give me negative 12, but add to give me b, which is equal to negative 4. So let's write down all our factor pairs of negative 12. 1 times negative 12, and negative 1 and positive 12. 2 and negative 6, and negative 2 and 6. 3 and negative 4, and negative 3 and 4. All of these pairs multiply to give me negative 12. Now we need to find the pair that adds to give me negative 4. These won't work. 2 plus negative 6, yep, that one's going to work. So we get 2 times negative 6 And 2 plus negative 6 is equal to negative 4. So these are our magic numbers that complete our math riddle. So we write our factored form by writing these two binomials using the magic numbers. So we have x plus 2 and x minus 6. And we can check this. By foiling the two binomials together, multiplying them out. X times x is equal to x squared. X times negative 6 is negative 6x. 2 times x is 2x. And 2 times negative 6 is negative 12. Combine like terms in the middle, and we get x squared minus 4x minus 12, which is our original trinomial. So yes, this is the correct factored form. This is in the form x squared plus bx plus c. Our c is equal to 72. I need two numbers that multiply to give me 72, but when I add them together, I get negative 17. So let's list our factor pairs of 72. 1 times 72 equals 72, and negative 1 times negative 72 equals 72. 2 divides 72. 2 times 36, and negative 2 times negative 36. 3 and 24, and negative 3 and negative 24, and 4 and 18, and negative 4 and negative 18. 5 does not divide 72, but 6 does. 6 and 12, and negative 6 and negative 12. 7 doesn't divide 72, and 8 divides 72. 8 times 9 equals 72, and negative 8 times negative 9 equals 72. We need to find the factor pair of 72 that adds to give us negative 17. That would be negative 8 times negative 9. So we get negative 8 times negative 9 equals 72, and negative 8 plus negative 9 equals negative 17. So we're going to write our binomials using our magic numbers that solved our math riddle. So we get x minus 8 and x minus 9 as our factored form. We can check it by multiplying out. X times x is equal to x squared. X times negative 9 is equal to negative 9x. Negative 8 times x is negative 8x, or minus 8x. And negative 8 times negative 9 is equal to positive 72. Combining like terms in the middle, we get x squared minus 17x plus 72, which is our original problem. So this is our factored form of our expression. This is in the form 1x squared plus bx plus c. Our c is equal to 1. We need factor pairs of c that add to give us b, which is negative 2. What are some factor pairs of 1? This one's going to be easier than last one. To multiply to get 1, we can do 1 times 1 or -1 times -1. And that's it. Which factor pair adds to give me -2? Well, it's -1 and -1. So when we multiply -1 times -1, we get +1. And when we add -1 plus -1, we get -2. So we use those magic numbers to fill in our binomials, x minus 1 and x minus 1. Now what's so special about this is that these binomials are the same. And we can simplify this just a little bit more by saying this is x minus 1 squared. This is in the form x squared plus bx plus c. Our c is equal to -8. We need factor pairs that multiply to give us -8, but when we add them we get b, which is -6. So we start by writing our factor pairs of -8. We can multiply to get -8 using 1 and -8, and -1 and +8, 2 and -4, and -2 and +4. 3 does not divide 8. 4 does, but we've already have our factor pairs with 4's in them. So these are all the different factor pairs that multiply to give us -8. We need to find one that gives us -6 when we add them. Let's try 1 plus -8. Well, that will be -7. How about -1 plus 8? That'll give us +7. When we add 2 plus -4, that's going to give us -2. When we add -2 plus 4, that's going to give us +2. None of these factor pairs of -8 add to give us -6. There is no factor pairs of -8 for which we get b, which is -6. So none of these will work. We've listed them all. So what we do is we say that this polynomial is prime. There is no way to factor this polynomial. A prime polynomial, if the only factors of a prime polynomial are 1 and itself, then the polynomial is prime. Now, for our next one, it is a little bit different. The reason why it is different is we have x's and y's in this trinomial. I want you to look at this in the form that we've been using, except that we have a y and an xy and a y squared term. But the form is still going to be the same. We have a coefficient of 1 on the x squared term. Our b is 8 and our c is 15. So take 15 as our c, and we need to find factor pairs of 15 that add to give me 8. So let's list our factor pairs of 15. We can multiply to get 15 using 1 times 15 and -1 times -15. 2 does not divide 15, but 3 does. 3 and 5 and -3 times -5. These are all the factor pairs that we have for the number 15. Which factor pair adds to give me 8? 3 plus 5. So 3 and 5 multiply to give us 15, but add to give us 8. So these are the numbers that solve our riddle. We're going to put our parentheses for our binomial. We're going to put our x in the same position, but we're also going to put a y in the second term of our binomials. Then we're going to use our magic numbers 3 and 5 and put them as the coefficients of our y terms in our binomials. So let's check to see if this gives us our original problem. by multiplying out these two binomials by FOILing. X times x is equal to x squared. X times 5y is equal to 5xy. 3y times x is equal to 3xy. And 3y times 5y is equal to positive 15y squared. Combine like terms in the middle and we get x squared plus 8xy plus 15y squared. And this is our original problem. So this is the factored form of example 7.